In this video, we will be discussing how we set up systems of equations in order to solve for two unknown values for a given word problem. So the first thing that we're going to need to do is we're going to define both unknown values using two separate variables. Once we've done that, we can write two different equations using the given information, and we can then solve the system using either the substitution method or the elimination method. After we've done that, we want to make sure that we answer the question in context. Let's look at a couple examples. So this first example here, we're given that a cell phone company makes two models of their cell phone. It takes 1 hour and 30 minutes to produce a standard model, and it takes 1 hour and 45 minutes to produce a premium model phone. The business can only produce one cell phone at a time, and if the company produced 6 cell phones working continuously for 10 hours, what we want to know is how many of each type it produced. So the first thing we want to do is we want to think about what are our unknown values. And the unknown values are the number of each type of phone it produced. So that's what each of our variables is going to represent. And there's two types of phones. So our first variable is going to be the number of the first model, which is the standard model, right? So we can use S. That's going to represent the number of standard model phones that were made. And then the other type of phone that they made is the premium model. So P is going to be the number of premium models that they made. All right, so now that we have defined our variables, the next thing we want to do is we want to think about the information that's given, and we want to write two separate equations that are using S and P. The first piece of information that we notice they give us is information about the time that it takes. So we're given that it takes 1 hour and 30 minutes, that's for the standard model, and then it's 1 hour and 45 minutes for a premium model. We're also given the total amount of time that they're working, so we're going to use that piece of information as well. We're given that they worked for 10 hours creating cell phones. So first thing we want to think about is we want to get all of the time in terms of just hours. So if you think about 1 hour and 30 minutes, that would be 1.5 hours. So it's 1.5 hours, and that's for the standard model. And so we're saying that it's 1.5 hours per every standard model. In other words, whatever the number of standard models that were made, we can multiply that by 1.5, and that's going to be the total amount of time that it took to make the standard models. So that's going to be the start of this first equation, is going to be 1.5 S, right? 1.5 times the number of standard models that were made. We're going to do that same thing for premium models. So premium models, it's 1 hour and 45 minutes. 45 minutes is 3/4 of an hour, or as a decimal, that would be 0.75. So we can say that 1.75 hours is the amount of time that it's taking to create a premium model. And again, if we multiply 1.75 times P, that's the total amount of time that is spent creating premium models. So we're going to add that on to the 1.5S. So 1.5S plus 1.75 P, that's the total amount of time creating standard and premium models put together. And we know that that has to equal 10 hours because we're given that that's the total amount of time that they spent working on creating phones. So that is our first equation. The next thing we want to do is we want to look at what other piece of information is given that we can use to set up an equation. The next thing that we're given is that the company produced 6 cell phones in total, right? So that means that the total number of standards and the total number of premiums have to add to be 6, right? Well, S and P, those are our variables that represent the number of standard models and premium models. So we can simply write S plus P equals 6, and that's going to be our second equation. So these two equations put together, that's what we call the system of equations. The next step is to solve, and we are going to solve this first one using the substitution method. So I'm going to leave a note that we're using substitution to solve. And how we solve using substitution is we take one of our equations and solve it for one of our variables. We're going to do this for the second equation, so the s plus p equals 6. Let's say we want to solve this equation for s. What we would do is we would subtract p from both sides of the equation. So it's going to give us s equals 6 minus p. So now that this equation is solved for s, we can do the substitution step, which is where we take the expression 6 minus p, and we're substituting it in for s in the first equation, right? Because this equation is telling us that s is equal to that expression, right? So we look for where s shows up in that first equation. We can see it's right there with the 1.5. So altogether, that's going to become 1.5 times, and then in parentheses, 6 minus p plus 1.75p equals 10. What this does for us is it gives us an equation that is only in terms of p so that we can then solve for p. So we're going to do that now. First thing we want to do is distribute the 1.5. 1.5 times 6 is, let's do some work off to the side here. So 6 times 1.5, 6 is 6. That'll give us 9. So we get 9 minus 1.5p plus 1.75p equals 10. Now we can combine like terms with the negative 1.5p and the plus 1.75p. So the 9 stays the same. When we combine those, that's going to become plus 0.25p equals 10. From there, we want to subtract 9 from both sides. Minus 9. So we have 0.25p equals 1. Now, what we could do is we could divide both sides by 0.25. Alternatively, what I like to do is I like to think of 0.25 we know as a fraction. That would be 1/4. And so if we want 1/4 to just be 1, we would simply multiply both sides by 4. So if we multiply both sides by 4, that becomes p equals 4. So we have our solution for p. Anytime we're solving a system of equations, once you've solved for one variable, it's super easy to find the other variable. You just go back to one of your original equations and you plug that value in for that given variable. So in this case, we know that p is 4. So if we take the second equation and we plug 4 in for p, that's going to become s plus 4 equals 6. And so then to solve for s, all we need to do is subtract 4 from both sides, so s equals 2. Right, so the very last thing we need to do is we need to answer the question in context, right? The question that we're being asked is how many of each type were produced. Well, now we know that there were 2 standard models and 4 premium models. And so that is our final answer in context. Let's look at another example. So here we have that Jenna and Sophia shared a box of chocolates. Jenna ate 2 more chocolates than Sophia. If Jenna had eaten half as many chocolates as she did, then she would have eaten 3 less than Sophia. What we want to know is how many chocolates they each had. So that's what our variables are going to represent. One of them is going to represent the number of chocolates Sophia had, and the other one is how many Jenna had. So we can let J represent the number that Jenna had, number of chocolates that is, and then S is going to be the number that Sophia had. All right, so from here, what we want to do is we want to set up our system of equations. So we want to think about how can we use the information given to write 2 separate equations. The first piece of information we're given is that Jenna ate 2 more chocolates than Sophia. So how we can write that as an equation is we can say that J must equal S plus 2, right? The amount that Jenna had is equal to the amount that Sophia had plus 2 more. The next thing we're given is that if Jenna ate half as many chocolates as she did, then she would have eaten 3 less than Sophia. So half of how many Jenna had eaten would be represented by 1/2 J, and we want that to be 3 less than Sophia, or in other words, we can write that as S minus 3. Now that we have our system of equations, the next step is to solve the system, and we are going to do so using the elimination method. So with the elimination method, what we need to do is we need additive inverses for one of our variables. So when we say additive inverses, it means that the coefficients have the same value with opposite signs. Before we do this, we want to make sure that both of our equations are in the same form. So that means that our variables, each variable needs to line up, as well as the constant terms. So for instance, we look at the left side of the equation, and in both equations, they're both in terms of just J. So that's good, the J's line up. We want to make sure the equal signs line up. Looking at the right side of the equation, we see that the S's line up and the constant terms line up. So that's our very first step with elimination. If the equations are not in the same form, the first step would be to get the equations in the same form. But we don't have to worry about that with this particular situation. We do have to worry about getting additive inverses for one of our variables. So we're going to do this for the S variable. If we take a look at our S's right now, they both have a coefficient of 1. So we have that same value, but what we need is we need them to be opposite signs. Right now they're both positive, so we want one of them to be negative. And so we can do that by taking one of our equations. We'll take the second one, and we're going to multiply that by -1. So that's going to give us negative 1/2 J equals negative S plus 3. So we only needed to do that to the second equation. That first equation is going to stay the same, so we can just copy that down right below. Right, and now we have additive inverses for our S's, and so we can go ahead and add the equations together. So negative 1/2 J plus J becomes 1/2 J. Negative S plus S, so because they're additive inverses, they add to 0. That is the elimination step, right? We're eliminating the S. It becomes 0, and so we don't even have to write that. And then 3 and 2 add to 5. So we eliminated the S. Now we have an equation that's only in terms of J. To solve for J, we can multiply both sides by 2. So that becomes J equals 10. Now to solve for S, well, now that we know that J is 10, we can simply take that 10 and plug it in for J. We'll use the first equation here. So that's going to become 10 equals S plus 2. Subtract 2 from both sides of the equation to solve for S, and we get 8 equals S. To write our solution in context, this means that Jenna had 10 chocolates and Sophia had